All right, so today we'll be doing solids. So this is my introduction. If you're going to do solids, a word you're going to come across a lot is the word volume. Now this says volume is the amount of space an object or a substance occupies. Volume is the amount of space an object or a substance occupies. All right, so you're talking about how much space something occupies, that is its volume. So the bigger a mass, the more space it occupies, and then therefore the larger is its volume. Now, the units of volume are millimeters cube, centimeters cube, meters cube, or kilometers cube. So volume is three-dimensional. Length is one-dimensional, area is two-dimensional, and volume is three-dimensional. So length would be centimeters, area would be centimeters square, and volume would be centimeters cube. Length is one-dimensional, area is two-dimensional, and volume is three-dimensional. Now, of course, the unit of area is square because whenever you calculate area, it always involves multiplying two lengths with the same unit. The unit of volume is cubed because whenever you calculate volume, it will always involve multiplying three lengths with the same unit. And so length is one-dimensional, area is two-dimensional, and volume is three-dimensional. Moving down, still sort of in our introduction. So the thing we're going to look at today, we're going to look at solid shapes with a uniform cross-section. Now, cross-section, a cross-section is a surface or a shape that is exposed when a straight line cut is made through a solid. A cross-section is the surface or shape that is exposed when a straight line cut is made through a solid. So for example, let us say you have an orange. An orange is largely, let us say, a sphere. An orange is largely, let us say, a sphere. An orange. If you cut an orange, like all of it, I mean, we're used to that. We have cut an orange before. If you cut an orange, what would be the shape of the surface that is exposed if you use a knife and just cut an orange in two? Anybody? What would be the shape of the surface that will be exposed? All right, nobody not answering. So I have my orange. I know I always distress teacher by doing that. Don't listen and then ask me to repeat. Them is a distress teacher, I know. This is my orange. I cut the orange in two. You see this surface, the surface that is exposed, it's called the cross-section. The surface that is exposed when I cut my orange in two is called the cross-section. What I'm asking you is, what is the shape of the surface that is exposed when you cut an orange? Anybody?
Sir, a circle.
Very good. Very good. It's not a sphere, it is a circle. The orange itself is a sphere. But when you cut the orange, the surface of the orange that is exposed when you cut it into is a circle. That surface is called the cross-section. That surface is called the cross-section. Guys, have you ever been to the doctor's office and you will see like the cross-section of somebody's inside? If you go to maybe the ear doctor, you will see a cross-section of an ear. If you go to maybe the whatever doctor, you normally see cross-sections. So you get a cross section when you make a straight line cut through a solid. The surface that is exposed is called the cross section. Guys, from the title, the word uniform means the same or remaining the same. So that is why when we go to school, they say we wear a uniform. It means that everybody wears the what? The same thing. So if you're talking about a solid with a uniform cross section, what we are saying is that for the length of the solid, the cross section is always the same. A word you're going to come across also is the word prism. Now, a prism is a solid figure with a base or ends which are parallel and congruent, and the sides are usually a rectangle. The sides are usually made up of rectangles. So, for example, I'll just try and do a quick example. This would be an example of a prism. It's a solid shape with a uniform cross-section and the sides are rectangular. It's not the only example. You can have a triangular prism as well. So this would be an example of a triangular prism. The ends are the same, meaning that I have I have identical triangles at both ends. If I cut this shape along its length, every single time I cut, I will always get a triangle. And the sides of this shape are rectangles. This shape has 3 sides and the 3 sides are rectangle. This shape is what you call a prism. It is a solid shape with a uniform cross section and the sides are rectangle. Guys, a prism gets its name from the shape of its ends. So for example, the ends of this prism are triangles. So we say that this is a triangular prism. The end of this prism is a rectangle. So we say that this is a rectangular prism. Another name for the rectangular prism is the cuboid. Guys, a prism is an example of a solid shape with a uniform cross-section. So the triangular prism, the cuboid, the cube, the cylinder, those are examples of a solid shape with a uniform cross-section. Guys, when we do this topic, one of the things we're going to have to do is we're going to have to calculate the volume of a solid shape with a uniform cross-section. Guys, the volume of all solid shape with a uniform cross-section is given by the formula V is equal to A multiplied by H. The formula for calculating the volume of all solid shape with a uniform cross-section is volume V is equal to A times H. Guys, the A in this formula stands for the area of the uniform cross-section, and the H is the perpendicular distance between the two ends. All right, so you'll see that in action in a second. Now, the total surface area, TSA, of a closed solid with a uniform cross-section is given by the formula total surface area, TSA, is equal to PH plus 2A. All right, don't stress yourself over it. You will see the formula in action. P in the formula stands for the perimeter of the uniform cross-section. H is the perpendicular distance between the two ends. And the A is the area of the uniform cross-section. All right. So I think it's important. As I said, the introduction for this topic was a little bit too long. So I think it's important now that I at least start showing you how to calculate volume and total surface area. So I'm going to do something now. I'm going to I'm going to show you, we're going to get a chance to see it in action, but I want you to get a chance to practice it. All right, so for example, I'm going to make the radius here 7 centimeters. 7 centimeters. I'm going to make the height here 20 centimeters. No, not 20. Let's make it 10 centimeters. All right, this shape is a cube. Now, a cube is like a die, you know, like you're playing games and you have to roll 2 dice. So this is a cube. For a cube, all the edges are of equal length. All the edges are of equal length. So let us say for this cube, the edges are 6 centimeters. All the edges are of equal length. Guys, these are examples of a solid shape with a uniform cross-section, the cylinder and the cube. All right. Now, let us see why. Why are these shapes solid shape with a uniform cross-section? Now, the shape at the top is a circle. The shape at the bottom is an identical circle. And if I cut this shape in the middle, let's say I cut this in the middle, what shape would be exposed if I cut it in the middle? Anybody?
An oval.
It wouldn't be an oval, but thank you for trying. If you have a circle at the top, a circle at the bottom, this shape is consistent.
Cone.
So what will be the shape that is exposed if I cut this solid in the middle? Anybody?
A circle.
The shape that would be exposed is a circle. Somebody say a cone. No, it wouldn't be a cone. The shape that would be exposed is a circle. So imagine that this is like a cylindrical bread. Imagine that this is like a cylindrical bread. You have a circle at the ends, circle at both ends. Every single time I cut a slice, what would I get? Anybody? Talk to me now.
A circle.
Every single time I cut it, I would get a circle. It's a cylindrical bread. Every time I cut a slice, I would always get a circle. So the circle that is exposed when you cut it is called the cross-section. And since the cross-section is the same for the entire length of the shape, we say that this is a solid with a uniform circular cross-section. It's a solid with a uniform circular cross-section. All right. Now, for the cube, remember, what will be the shape at the top and the bottom of the cube? Anybody?
A square.
Square. Very good. What would happen if I cut this cube in the middle? If I cut the cube in the middle, what shape would be exposed if I cut it in the middle?
Rectangle. Rectangular prism.
Oh, it be rectangle. The thing is a square. If the top is square, the bottom is square, anywhere you cut it in the middle, you'll always get a square. So the cube is a solid shape with a uniform square cross-section. All right, now, what I did next here is, these are like the formulae. The formulae for calculating the volume. These are all examples of a solid shape with a uniform cross-section. And the formula for calculating the volume of all solid shape with a uniform cross-section is V is equal to A times H. Every solid shape with a uniform cross-section, the formula for calculating the volume is V is equal to A times H. Guys, for the cylinder, what is the shape of the cross-section?
Circle.
Circle. Good. So the area, in the formula, A is the area of the uniform cross-section. So because for a cylinder, the cross-section is a circle, the formula is V is equal to A times H. its V is equal to what? Pi r square h. Guys, the formula for the total surface area is V is equal to PH plus 2A. P in the formula calculates, P in the formula is the perimeter of the uniform cross-section. Guys, what do we call the perimeter of a circle? Anybody?
Sir, the circumference.
The circumference, very good. So the formula is what? PH, which is same as saying what? 2 pi RH plus 2A. Now 2A are the 2A, the A in this formula is the area of the uniform cross-section. So the A here would be the what? The area of this circle and the area of the top circle. Guys, listen carefully. PH, guys, give me the area of the sides, and 2A would be the area of the top plus the area at the bottom. Now, let's say this again. The formula is PH is equal, TSA, which stands for total surface area, is equal to PH plus 2A. Guys, you see this solid shape? The cylinder, it has 3 surfaces. The cylinder has 3 surfaces. There is the curved surface at the side, and there is the circle at the top and the circle at the bottom. If you are calculating the total surface area, what you're calculating is the area is the sum of the area of all 3 surfaces. I'll say it again. The cylinder has 3 surfaces. There's a circle at the top, a circle at the bottom, and there is what? The curved surface in the middle. Now, let's start explain that now. PH calculates the area in the middle. 2A would be the area at the top and the area at the bottom. At the top, you have a circle. The area of the circle is pi r square. At the bottom, you have the same circle, pi r square. Pi r square plus pi r square is 2 pi r square. Guys, PH gives you the area in the middle. The area in the middle is what? 2 pi r, which is the perimeter of the cross section, times the height. Kezia, I see you raise your hand. You have a question
So
to
I was
ask?
asking if the sir, for the cylinder, sir, the part in the middle, would it be the same as the sector with the 2 straight sides as the radius and the curved side as the length?
No, it's not a sector. As a matter of fact, if you open out this shape, it will look like this. If you open out the cylinder, it will look like this. Meaning that if you open out the cylinder, that's how it would look. You'd have a circle at the top, a circle at the bottom, and a rectangle in the middle. Guys, stay with me. Now, very quickly, I'm going to calculate the volume and the total surface area of this shape. Very quickly. Now, the volume for all solid shape with a uniform cross section is V is equal to A times H. Guys, A in the formula stands for the area of the uniform cross section. Now, the uniform cross section is a circle. The cylinder is a solid shape with a uniform circular cross section. So the volume, the formula would be V is equal to pi r square h. This would be 22 over 7 times r, which is 7, times r, which is 7, times the height of the prism, which is 10 centimeters. This cancels this. 22 times 7 is 154. 154 times 10, this is 1,000 540, and the unit for volume is centimeters cube. So that is how I would calculate the volume of a cylinder. Now, guys, how would I calculate the total surface area? The total surface area, TSA, would be equal to pH plus 2A. Listen carefully. pH, calculate the area of the sides. Most of these solids have what? Well, let me not say three surfaces. The cylinder has three surfaces. I have to be careful what I say to you. So pH calculate the area in the middle. pH calculates the area in the middle. Now, 2A would be the area at the top plus the area at the bottom. The shape at the top and the shape at the bottom are identical shapes. So it would be A at the top plus A at the bottom. That would be 2A. So 2A would be the area of the top and the bottom. pH gives you the area of the middle. Guys, P stands for the perimeter of the uniform cross-section. The uniform cross-section here is a circle. The perimeter of a circle is called the circumference. So this is 2 pi RH plus 2 pi R squared. So this would be 2 times 22 over 7 times the height of the prism, which is 10, plus 2 times 22 over 7 times 7 squared. All right, so what I have here is 440 divided by 7 plus over here, this 7 cancels one of these 7s. This is 22 times 7, which is 154 times 2. This is 308. 308. So it's 440 over 7. I'm getting my calculator. (440) divided by 7. All right, this is 62.9. So this would be 62.9 plus it's 2 pi r. I know something was missing. Something is definitely missing. I thought it was too low. And nobody never tell me, sorry, I made a mistake. It's 2 times 22 over 7 times r, which is 7 times 10. This 7 cancels this. So this is 440 plus 308. The entire volume would be 748, sorry, not volume, total surface area, and this would be centimeters squared. All right, so that is how you'd have to calculate the volume and the total surface area of a cylinder. Guys, are there any questions? Any questions about what I just did? I'll reiterate that, please listen, that for the formula TSA, pH calculates the area of the sides. 2A would be the area of the top and the area of the what? Of the bottom. All right. So for example, like for the cube, the volume is the volume for the cube is V is equal to AH. A, the formula, is the area of the uniform cross section, which is a square. So it's L times L, which is L square is the area of the square, times the height. But all the lengths, all the edges of the cube have the same length. So the height is also equal to L. So the volume of a cube is what? Is L cube. Just like how the area of a square is L square, the volume of a cube is L cube. Guys, the cube, all 6 surfaces, the cube has 6 surfaces. Everybody should know that. For example, because the example I gave is that of a die. The die that you use when you play games, it has 6 sides, and on each side you have the numbers 1 to 6. So the cube has 6 surfaces, and all 6 surfaces have the same area. So ultimately, the total surface area is going to work out to be the area of one surface multiplied by 6, because all 6 surfaces have the same area. I did tell you that the introduction is going to be a bit long. So this is called the cuboid. Another name for the cuboid is the rectangular prism. And the cuboid is a solid. The cuboid is a solid shape with a uniform rectangular cross-section. The volume is equal to V times H. The volume is equal to A times H. The A there stands for the area of the uniform cross-section, which is a rectangle. So that is why the volume of a cube, of a cuboid, is length multiplied by width, which gives you the area of the cross-section, times H. So the volume is what? Length multiplied by width multiplied by a height. The total surface area would be the perimeter of the cross-section times the height, plus now the area of the base, the area of the top, and the area of the bottom, which is the 2A. 4 is a triangular prism. Another name for the triangular prism is a wedge. So you have a triangle at both ends, and all 4 sides are rectangle. All 3 sides are rectangle. All right. The volume is equal to V times H, A times H, and the total surface area is PH plus 2A. Also of note, please note that the cross section and the height are always at right angles to each other. So for the cuboid, the cross section is horizontal, the height is vertical. For the wedge in our diagram, the cross section is vertical, the height is what? Horizontal. So it is the height, and another name for the height would be the length of the prism. Guys, these are other examples of solid shapes with a uniform cross section. All right. The first one, the uniform cross section is a sector. The uniform cross section is a sector. For the second one, the uniform cross section is a pentagon. For the third one, the uniform cross section is a composite shape, which forms a L. These are all examples of a solid shape with a uniform cross section. All right, the last thing in the introduction is this: volume of a liquid. Now, a liquid takes the shape of its container. This is a fact that is going to come in very important as we progress through the lesson. A liquid takes the shape of its container. And guys, the unit of a volume of liquid is liter, and 1 liter is equal to 1,000 centimeters cube. This is knowledge that the examiner will want you to have. You'll have to know that before you go into an exam, that 1 liter is equal to 1,000 centimeters cube. All right. And largely, ladies and gentlemen, give me a second. Largely, ladies and gentlemen, that is the introduction to volumes. Next, we're going to look at some examples.